Hello, I'm KM, an associate professor in the School of Life Sciences, the Chinese University of Hong Kong. This video in biochemistry and public health is the first one on metal intoxication. We have 4 videos. First is about the background on essential and non-essential metals. Second is on the toxic effects and risk management of arsenic and cadmium. Third one on lead and mercury, and finally, some discussions on health risk management with group discussions, case studies in the 4th video. The sources of metals could be from natural inputs and anthropogenic inputs. Natural inputs are mainly from sediments, volcanoes, forest fire, while the anthropogenic sources or inputs from human beings are from industrial dumping, mining, agriculture, sewage and sewage sludge, fly ash from incinerators, burning of fossil fuels, and atmospheric sources in general. We often call metals as heavy metals, referring to those with a specific gravity greater than 5, since the metal ions are in trace amount. Collectively, we call them trace metals. The amount we are talking about is ppm parts per million to ppb parts per billion levels. It is also important to note the various forms or valencies of metal ions as they dissolve in water, become ionic with multiple forms or valencies. There are also organic forms, mostly methylated. Usually, the metallic form as solid metal is not toxic at all if they never get dissolved. Here's the periodic table. As you can see, the relationship of essential marked in green and non-essential elements marked in black. The transition elements in the middle of the table, those in black are non-essential. They could replace the ions of the top row with the same outside shell of electron numbers. For instance, silver and cadmium can replace copper and zinc, arsenic to replace phosphate, and so on. Nickel, once thought non-toxic but found to cause cancer in mine workers. Your far right-hand side, the halogens, they could be essential, like iodine, but high concentration could cause health problems. Your far left, with calcium, magnesium, are light metals, also useful to many cellular functions. There are different types of metals with biological functions or concerns. Light metal refers to calcium or magnesium. We need them for biological functions, usually have problem in deficiency. Transitional metals include iron, copper, cobalt, manganese, and zinc. They are essential elements or ions in water. They become toxic at very high concentration, and usually we have health problems when in deficiency because they are essential to health. Finally, the metalloids such as mercury, cadmium, tin, arsenic, aluminum, etc., they are non-essential ions. Even a little bit could be toxic, and we have to avoid them. With these concepts of chemistry in your mind, essential metals and elements are those needed and required in our body under homeostatic control or tight regulations. They include copper, cobalt, iron, iodine, zinc, manganese, selenium, vanadium, common-free, molybdenum, etc. There are non-essential elements not required in health. They are toxic and harmful because they interfere with the essential elements. Non-essential metals include aluminum, arsenic, cadmium, lead, mercury, nickel, chromium-6, antimony, etc. Note the 2 forms or valencies of chromium. Chromium-3 is essential and non-toxic. Chromium-6 is non-essential and toxic. Non-essential elements in our body are difficult to confirm as they may exist in our body as contaminants, and we do not know the required amount exactly. For example, chromium-3 was found in a hormone called insulin, but its exact function is not known. Many essential elements have important roles in biological functions. For instance, iron, Fe2+, is needed in hemoglobin for oxygen transfer. Copper is found in marine invertebrates also for oxygen transfer in hemocyanin, not hemoglobin, in the blood. In fact, copper and zinc are required in many enzymes as cofactors. Cobalt found in vitamin B12 in our gut. Magnesium for ATP binding to kinases. Selenium is a scavenger of peroxides, reducing cancer risk as antioxidants. Therefore, many essential elements have multiple functions: brain and endocrine functions. Transition metals form tetra, hydro, or structural and catalytic roles in enzymes. They are also important for DNA and RNA synthesis, removal of superoxide radicals. Last but not least, they help with bone and blood formations. As non-essential elements take over the normal essential elements, many enzymes not functioning in a proper way and could be very serious. For instance, arsenic causes skin problems called blackfoot diseases, as shown here with skin problems in the hand on the right top photo. Mercury is also famous for its neurotoxic effects that could last for a lifetime and transmitted from mothers to the babies with fetal effects or second generation. Non-essential elements are generally toxic. They could be carcinogenic, like arsenic, nickel, cadmium, and they are found as tumor or cancer promoters. Mercury is not carcinogen, but a neurotoxic substance similar to lead. Lead could also be hemotoxic. Cadmium causes renal dysfunction and also found in lung cancer or many pulmonary problems. We could get cadmium via smoking to get into our lungs. Arsenic is usually related to hepatomegaly. Lastly, let's take a look at detoxification of metal intoxication. We have antidotes for metal intoxications. These drugs compete for binding of metals to biomolecules. We call this chelation therapy. Urinary excretion is the major mechanism for detoxification. For example, EDTA, ethylene diamine tetraacetate, calcium or sodium ions are useful to remove cadmium and lead, despite of the low efficiency. The second group of antidotes are thiol drugs, drugs with sulfur hydride SH group, which binds with metal ions. Monothiols depend or dipenicillamide. Dithiols include dimercaptopropanol, dithioglycine, diethyl dithiol carbamate, also Saxima. DMSA, dimercaptosuccinic acid, is an oral drug effective for removal of excessive metals. Thank you for watching. I hope you have now learned the biological functions of some essential metals. As non-essential metals replace them and become toxic, we can use antidote to remove them. At the same time, during this chelation therapy, we need to provide supplements of essential elements. However, the damages done, especially neurotoxic effects, could not be recovered because nerve cells could hardly be regenerated. Bye-bye.